Welcome back. In our last lesson, we learned how to properly evaluate a model by splitting our data. Today, we'll explore the most common problems that this evaluation process helps us uncover: underfitting and overfitting. The ultimate goal in machine learning is to create a model that generalizes well. That is, it makes accurate predictions on new data it has never seen before. Underfitting and overfitting are the two main reasons a model fails to do this. Think of it like getting a suit tailored. An underfit suit is like a giant sack. It doesn't fit anyone well. An overfit suit is tailored so tightly to one specific pose that you can't move or sit down. We want the suit that fits perfectly and lets us move freely. Let's start with underfitting. This happens when our model is too simple to capture the underlying pattern in the data. The symptom of underfitting is easy to spot. The model performs poorly on the training data, and it also performs poorly on the test data. It just isn't learning effectively at all. Overfitting is the opposite and more common problem. This happens when our model is too complex. It learns the training data so perfectly that it memorizes not just the important patterns, but also all the random noise and fluke details. The symptom here is a huge gap in performance. The model gets a near-perfect score on the training data, but fails badly when it sees new data in the test set. Our goal is to find the Goldilocks model, the one that's not too simple, not too complex, but just right. This model is complex enough to capture the important, true patterns in the data, but it's not so complex that it starts memorizing the noise. This is the model that will generalize best to the real world. So how do we diagnose this? We watch the model's error on the training set and the validation set as it trains. If both errors are high, the model is underfitting. But if the training error gets very low while the validation error starts to get worse, that's the telltale sign of overfitting. The gap between the two error rates reveals the problem. And now you understand one of the most fundamental challenges in machine learning. Finding this balance is what so much of model development is about. This practical problem is actually the result of a deeper, more theoretical concept. In our next lesson, we'll explore that theory as we dive into the famous bias-variance trade-off.